Why is there a P? The P here is that some of the views I may express can be relative views. So if I were to express views just on the single assets themselves, P would be equal to identity. But I can say something, which is the fact that I believe that emerging market returns are going to be higher relative to US markets. In order to express some relative views, then I need something that is a matrix P, okay? Which adds to the complexity a little bit. And what happens is that I have got also a matrix which is the C or epsilon matrix. What is that? This matrix is here to identify the degree of confidence I've got in my view. Because I have some view, and therefore the differential between the two is important. But I have to say that these views, I trust them or not. And maybe I can say that with respect to gold, I think that the return is going to be different. But gold is a difficult asset class, therefore I've got limited confidence into that. While if I'm looking at bonds, I know that bonds are going to be, the rates are going to go up. As a result of that, I'm going to have a higher confidence in that. And therefore, the confidence is going to be expressed through something which is this epsilon matrix, which is going to have an impact on tilting, in fact, the dependency on the assets to some extent. Okay? So, now, if I simplify this to assume that I've got no P but the identity, what happens is that this is the new matrix here, which is the new x, the new weight, so with a square minus the initial x, is going to be equal to epsilon plus sigma power minus 1, which is going to incorporate the confidence level, multiplied by the differential between the view and the return. Okay? So this is the way it works. And as a result of that, and in fact, you can see that here I have got something that is quite nice in the sense that I can tilt my weights in the portfolio as a result of my view and as a result of the confidence level in the portfolio. Now, always something that is a bit worrisome, which is that it depends, all of that, on the sum of two matrices which are inverted, and the inversion of such matrices is not something that is great to do, especially when the assets are really correlated. Just to give you an idea here of what it means, and this is something that sometimes can be quite tricky. I have here, in fact, in blue, I have got my views. In yellow, I have got the equilibrium returns, the way they look. Okay? And in fact, what I'm having is the blended returns corresponding to the mixture of the two for various asset classes, which are government bond, high yield bond, developed equities, commodities, and fund of hedge funds. So what you can see here is that from, well, in fact, there are more than that. I'm sorry, because not all the asset classes, there is 1 out of 2. So it's going to be government bond and etc. But let's call them asset 1 to asset 7. 1, 2, yes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Asset 9. I've included, by the way, I've included cash in here, which was not something that was coming out of the portfolio. But what you can see is that, and this is something which is sometime a bit tricky, which is that in that case, if I take some of the assets, which if you think of the asset number the various assets. So here, on government bonds, my views are higher than the market. As a result of that, it increases the allocation to government bonds. If I'm looking now at various asset classes, you can see that not all the asset classes are going to have going to be impacted in the same manner. So the third asset here, high yield, is going to be impacted here. But if I look at this one, the fourth asset, actually it's not going to be impacted. Sorry, this is the 1, 2, 3. Yes, it's here. If I look at the fourth asset, which is US equity, it's going to be impacted, but it's not going to be impacted more than this asset, which is this one. It all depends on the various correlations. So in fact, it's a complex dependency. It is what I said here, is that trying to think in one's mind what is going to be the impact of the black determinant approach is difficult, because you've got the views tilted by the fact that the inverted covariance matrix is something hard to model. In addition to that, the degree of confidence I have into that brings some degree of uncertainty in addition to that. So it's not highly predictable here. But it is interesting, because as a result of that, you can see that I'm tilting what is the market recommendation by something that can go between 5 and 10%, depending on the degree of confidence I've got in my views. Okay, so it's adding a certain level, at least intellectually, a certain level of flexibility. What we're going to see after that is whether all of that delivers, and why, if it doesn't deliver, why does it doesn't deliver? Okay, and looking at some of the weaknesses of the mathematical modeling. But what I suggest is right now we have a break, and we come back with the second slide. Thank you.
Yes, a lot, yeah. This term, 3 courses, and the applied project master.
All right, okay. Yes. What are you doing that on?
Comparing different. Variants, US volatility, equal risk profile, stuff like this, and comparing how they perform in different market conditions. Yeah, mainly is that one is like saving well. Yeah, yeah. I saw it. I went to the next slide. Interesting.
So what do you
that 30 and try to allocate those. Not doing like cross asset classes, and just trying to optimize one on. And then what
it's not going to be vastly different from the one divided by n.
I'm joking, no, you're not.
Would have done it, but
Your estimation period on which you work is going to be probably
sure how to handle it.
one of the things that I would do.
Are you using a rolling window?
No, but do this. Here is my suggestion to you. You know what EWM is?
How is it?
Let's see.
How many questions?
This one. Like pure.
I'm able to back out because basically from this I can back out the correlation.
You know me too well.
Yep.
So I'm starting from V1.
I mean, it's a rolling window, so you start with the first value, always adding one anyway.
But why the others need to benefit from 5 p.m. finishing up class for the day.
Would apply to this course. Would apply to this course if you're dedicated. Would apply to this course.
Yeah, you should finish up like walking out the library at like 11:45. Like finishing the day. That would be hilarious. Then you get a message tomorrow. Sorry, I was trying to portray realism and accuracy. They said, really? Is this Ranch of Hill? No idea. Oh my god, this was actually have a life.
Guys, is it okay if we go back? In passing, I was discussing with one of you here. I think that it is maybe there is one thing I can add, because it's to give some intuition. You know, whenever we are talking about correlation, it's not very easy to understand what we mean. So what I'd like to give you is an idea about what is the why does correlation evolve, and how does it work, okay? So assume that I have got, and I'm sorry for the one who has been there, but I'm just looking at this, because getting a feel for return is very easy. Getting a feel for correlation is not that easy. So I'd like to share that with you. In fact, I'm looking at two asset classes, okay? I'm looking at asset 1, and I'm looking at asset 2. For each of them, I am going to have series of returns or excess returns, okay? So it's going to be return 1, which is starting at period 1, to return 1 at period large t. And then for return 2, 1, 2, return 2 at t, final t. How can I express correlation here? Well, in fact, it's going to be, if I look at asset 1 versus asset 2, so let's assume that I've got 10 periods of time, okay? So I have got, in fact, during this first period, period 1, the excess return is negative. During the second period, it is positive, then negative, 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 positive, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So these are the 10 periods, okay? If I look at asset 2, then it is in fact starting with positive, negative, 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 positive, and then it is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then it is positive, negative, negative, positive, positive. Okay? So how do I measure the correlation between these two guys? Well, one simple way is to say that I have got 10 observations. So the number of pairs I can build is 10. The pairs are actually going to be, look at that, pair 1 is going to be negative, positive. Then pair 2 is going to be positive, negative. Then pair 3 is going to be negative, negative. Pair 4 is going to be negative, negative. Pair 5 is going to be negative, positive. Pair 6 is going to be positive, positive. And then it's going to be negative, 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 positive, positive, and positive, positive. So in order to measure correlation, because correlation is co-movement, what I'm going to say is just do something very simple. It is count the number of concordant pairs on total number of pairs. So my correlation in a way between these two is going to be, I have got 1, 2, 3, 4, 5, 6, 7, 7 out of 10, which is 70%. Okay? My pair correlation is going to be 70%. Now, So it's a very intuitive way to look at it. Now let's have a look at this. Let's introduce the other observation, which is that market conditions are evolving. And as a result of that, in fact here, I have got benign market conditions here, and these are volatile market conditions. So here there is growth, and here let's say there is recession. Okay? So in fact what I have is 1, 2, 3, 4, 5. So I'm in fact 1, 2, 3, 4, 5. I'm grouping all of these and all of these. What do I observe is that this 70% correlation on average is in reality something which is 2 out of 5 during benign conditions, which is 40%, and 5 out of 5, which is 100% out of 5, sorry, which is 100% during recessionary as opposed to growth. Okay, so you can see that with this very intuitive element here, that there is a reason why, in fact, the covariance matrix is not going to be stable, that depending on in which market conditions I am, I'm going to find very different conditional correlations. Okay? So you can understand when I'm saying it's hard to understand, to estimate the covariance. The covariance is, in fact, the correlation multiplied by the volatility of each of the assets. So the volatility is something fairly simple. But here the covariance may vary very much depending on the periods of observation I have. So assuming that I'm doing that purely on 2008, I'm going to be in this period where I'm going to find a correlation of 100. Therefore, portfolio construction taken on a recessionary period means there is no diversification. I don't need, in fact, to have plenty of assets. Where diversification is bringing me value is when market conditions are benign. Other than that, I'm not benefiting from diversification to the same extent. So you can see that on all what we've done before, this story about considering one static covariance matrix, assuming hence one static correlation matrix,